Now we will talk about a form of scalability called variety. In this case, scale does not refer to the largeness of data. It refers to increased diversity. Here is an important mantra you need to think about. When we as data scientists think of data variety, we think of the additional complexity that results from more kinds of data that we need to store, process, and combine. Now, many years ago, when I started studying data management, we always thought of data as tables. These tables could be in spreadsheets or databases or just files, but somehow they would be modeled and manipulated as rows and columns of tables. Now, tables are still really important and dominant. However, today, a much wider variety of data are collected, stored, and analyzed to solve real-world problems. Image data, text data, network data, geographic maps, computer-generated simulations are only a few of the types of data we encounter every day. The heterogeneity of data can be characterized along several dimensions. We mentioned 4 such axes here. Structural variety refers to the difference in the representation of the data. For example, an EKG signal is very different from a newspaper article. A satellite image of wildfires from NASA is very different from tweets sent out by people who are seeing the fire spread. Media variety refers to the medium in which the data gets delivered. The audio of a speech versus the transcript of the speech may represent the same information in 2 different media. Now, data objects like news video may have multiple media: an image sequence, an audio, and closed caption text, all time synchronized to each other. Semantic variety is best described through examples. We often use different units for quantities we measure. Sometimes we also use qualitative versus quantitative measures. For example, age can be a number or be represented by terms like infant, juvenile, or adult. Another kind of semantic variety comes from different assumptions or conditions on the data. For example, if we conduct 2 income surveys on 2 different groups of people, we may not be able to compare or combine them without knowing more about the populations themselves. The variation in availability takes many forms. For one, data can be available real-time, like sensor data, or it can be stored like patient records. Similarly, data can be accessible continuously, for example, from a traffic cam, versus intermittently, for example, only when the satellite is over the region of interest. This makes a difference between what operations one can do with data, especially if the volume of the data is large. We'll cover this in more detail in Course 2 when we explore the different genres of data and how we model them. We should not think that a single data object or a collection of similar data objects will be all uniform in themselves. Emails, for example, is a hybrid entity. Some of its information can be a table, like shown here. Now, the body of the email usually has text in it. However, some of the text may have ornaments around them. For example, the part highlighted in yellow represents something called a markup on text. We'll get to markups later in the course. Emails contain attachments. These are files or embedded images or other multimedia objects that the mailer allows. This screenshot from my Outlook shows the image of a scanned image of a handwritten note. When you take a collection of all emails from your mailbox or that from an organization, you will see that senders and receivers form a communication network. In 2001, there was a famous scandal around a company called Enron that engaged in fraudulent financial reporting practices. Their email network, partly shown here, has been studied by data scientists to find usual and unusual patterns of connections among the people in the organization. An email collection can also have its own semantics. For example, an email cannot refer to, that means cannot copy or forward a previous email. Finally, an email server is a real-time data source, but an email repository is not. Thus, email and email collections demonstrate significant internal variation in structure, media, semantics, and availability.